Hello, I am going to be running through the lesson here on relationship matters. Please find this in your math book. I will have you follow along with your pages, and anything that I write, make sure that you're writing. And then as soon as you finish that, you're going to show me your notes. We'll talk about it and you can move on to the next activity. So first up on page M3-7, remember that's module 3-7, we're going to warm up and think about powers. So this might be something new for you. That's why we're going to review quickly about what a power is. And I'm going to get my handy dandy pen ready. So we want to write each power of 10 as a product of factors. Remember, a product is the answer to a multiplication problem, and factors are the numbers that you are multiplying together. Okay, so simply put, we have 10 squared. Okay, that actually means 10 times 10, which I hope we know is 100. Okay, so 10 to the 5th on number 2 is going to be 10 times 10 times 10. How many times? Oh, I hope we know it's going to be 5 times. So that's 1, 2, 3, 4, 5. Now, an easy way to get the answer to this is we all know that 1 times 1 is 1. So all those ones multiplied together is 1. And then I can count up the zeros. I have 1, 2, 3, 4, 5 zeros. Well, that's interesting because that was my power there. That was my, what I call baby number. Okay, you're going to hear me say that a lot. So 1, 2, 3, 4, I'll sneak in another one, 5. So that would actually be 100,000. Okay, so pause the video and go ahead and fill in the rest of those answers. Now, I'm not going to go ahead and write that, but I will check that when I come check your notes. This isn't in your book, but you know we like to know where we're trying to get to and what we're trying to accomplish. So we are going to be evaluating algebraic expressions, and we have a lot of foundations to build here with this. That's why we're kind of watching these videos, hopefully outside of class, so we can come in and practice. We're going to have several vocabulary words to go over and lots to do. So our target is to be able to take an algebraic expression and then solve it when we know a certain number for the variable. Now, you might recall a variable is actually a letter that represents a number or a given value. But I'm going to go over all of it. Okay, so don't worry if that doesn't make sense just yet. Carnegie gives us our learning goals. So we're going to interpret a raised number to a positive integer, those powers we were working on. And we're going to talk about perfect squares and perfect cubed numbers as well. Page M3-7, we have our key terms. Today we're going to learn power, base, exponent. Hopefully soon we're going to get to perfect square and perfect cube. We're also going to talk about evaluating and then get into order of operations. Some of you had that in 5th grade, so some of you already have a jump start. Now, the first thing I want to share with you is an expression. Expressions are just different ways to show a number. So you might think about change. If I need 25 cents, there's a lot of different ways that I can make 25 cents. I could have 2 dimes and a nickel. I could have a quarter. I could have 25 pennies. They are different ways of getting the same amount of money. Recall that an expression in mathematics is a number or a combination of numbers and operations. The number 8 is an expression. We could say 2 times 2 plus 4 is an expression. It still equals 8, right? Because 2 times 2 is 4. Then I add 4, gets me 8. Okay, so now we're going to try it. Page M3-8, number 1, write an expression that's equal to 10. Okay, now we're not going to worry about the rest of it. I just want you to think about how can I make 10? You want to think addition, subtraction, multiplication, and division. Okay, so right away, if I'm thinking about addition, I know that 5 plus 5 is 10. That's an expression. Okay, subtraction. Well, I could think about 15 minus 5 equals 10. Okay. Multiplication. I can think about 2 times 5 equals 10, and then division. 20 divided by 2 equals 10. Those are all ways that I can make 10. They all equal the same amount. I'm just using different numbers and different math. So remember, when you're writing this down in your book, pause it if you need to, and then come right back in when you get done writing it down. Okay, same page. Now it's your turn. Write an expression equal to 8. Okay, don't worry about this. Okay, but I do want you to use addition, subtraction, multiplication, and division. Okay, you try it, and then when I look at your notes, I'll check it. Okay, good luck. Okay, when you get that done, we're going to go right into page M39. This is where we start diving into vocabulary, okay? And there's going to be booklets to practice the vocabulary. So it's very important that you're highlighting these and that you're working with the words, okay? We know that repeated addition is multiplication. We can also multiply over and over again, okay? So repeated multiplication is represented as a power, okay? Now, power is 2 to the 4th power altogether. So you have the 2 and then the little floating baby 4. Together, they make up what we call the power. The base, then, is just the 2. That's just the 2. The exponent is the little baby 4 up there. I call it baby because if you can tell, it's smaller than the 2 and it's up. Okay, it's up a little bit higher. You're going to have to be able to identify these, okay, and you have to know what it means. I want you to notice in this example that 2 to the 4th power has 1, 2, 3, 4 2's multiplied by each other every single time. Now, this is not 8, okay, because think about it. I have 4 2's. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So if you're told to evaluate or solve it, your answer is actually 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, I'll practice that more with you. Now, if you don't have all that written down, pause it. Make sure you have it written down before you move on. M39. This is more explanation of what I just showed you. And we can see the word base and exponent. Okay? The base is the factor that is multiplied repeatedly. You see it over and over and over again. The exponent is the number of times we see it being multiplied together. So question number 1, identify the base and the exponent. Then you're going to write each power in words. Okay, we're going to take it a step further. We're going to write what it means, and then I'll show you how to do it on a calculator maybe in another video. Okay, because this is a big one. 7 to the 5th power, that's going to be a pretty big number. Okay, so the important thing is which number is the base? Well, the base is the number 7. Okay, I'm going to highlight it yellow. The exponent, I'm going to highlight green, and then I'll write it. Exponent is 5. So what does that mean when I write it out? That means I'm going to multiply 7 times 7 times 7. I'm going to do that how many times? 5 times. Now, I would never give you an exponent one that big and expect you to do it in your head, okay? Because 7 times 7 is 49. Then you have to take it times 7, Take it times 7, take it times 7. I would hand you a calculator and you could put that math in and it would give you the answer. Okay? So don't worry about solving big ones like that just using your head. Okay? Same page, we have another one. See how we're working B right here? Okay? So the base would be the number 4. Exponent is the number 8. What does that look like? 4 times 4 times 4. How many times do I have to do this? Oh my goodness, I'm going to lose track. 8 times. So that's 1, 2, 3, 4. 5 times, 6 times, 7 times, 8 times. Once again, that's going to be a huge number. Okay? So I would let you use a calculator to solve that. No worries. This, my friends, is a super duper idea that we need to understand a lot for our foundational skill. Where I'm moving to is just kind of a quick review to see how is it tied to area and volume. It's just, we're just touching on it and then we're moving on. Okay, so this is kind of a simple idea. You don't have to get too into just kind of a slight connection that some of you might be able to make. Remember that the area of a rectangle, we're on page M39, we multiply the length by the width. Because all sides of a square have the same length, the area of a square is calculated by multiplying the length of the side S by itself, okay, because the square is the same size. So if this is 3, you got to multiply it by 3. What they're saying is if the length of the side is used S instead of a number, we're going to multiply whatever it is times itself, S times S, which then we can rewrite as S squared now that we have this new knowledge of powers. Okay, we call that squared. Okay, a square of a number. Okay, now, same page, we're going to take a look at this square. We know to find the area, we take the base times the length, or the length times the width, the base times the height, however you want to think about that. So that's 9 times 9. Since it's the same number multiplied by itself, that becomes our base. The exponent becomes, how many times do we have to multiply 9 times each other? I see 1, 2. So my exponent will be that floating 2. Okay, now rewind and listen to that again if that didn't make sense. The length of the side is going to be the base. The power, or the exponent, will be how many times do we have to multiply that times each other to get the area? Well, that's going to be twice. We take 9 times 9. That's 2 9s. Okay, so what I want you to do is try B by yourself. And we will not make this so complicated. Mark out the 0.75. Just think about it as a 2. And then I also want you to try M3-10, so we had to flip the page, C. Okay, I want you to try C. Instead of 2/5, though, I'm going to put a 5. Okay, just writing it like I did on this one. That's all I want you to do. Now, if you know the answer, you can solve it. I know that 9 times 9 is 81. Okay, so you guys are going to do B and C. And I'll either check it in class or I might upload a walkthrough video of an example and you can check yourself that way too. There's also a D. Look at that. You can do that one as practice too, just to get the hang of it. Okay, now, moving on page 10, we're going to extend that idea from area to volume right here. Okay, now as you can see, there is a vocabulary word, perfect squares. 9 is a perfect square because 3 times 3 is 9. So the answer to all those questions, 3 times 3, 4 times 4, 5 times 5, are called perfect squares. There's going to be a table later on that will help kind of give you an idea of what that looks like. Okay, now, volume, remember, is length times width times height. We have